Hi viewers, this is Sri Ramulu. So today's topic is transverse vibrations of a bar clamped at both ends. Clamped means fixed at both ends. So for example like this, if it is a bar having length L, so this end and this end, both ends are fixed like this, right? Two ends. So let it is a beginning end. At beginning end we have to take it as 0, and this end as x is equals to L. Why? Because from here to here distance is L. When the bar is fixed at both ends, following boundary conditions valid. So such these conditions are valid. So both ends are fixed, then displacement 0, and their derivative of slope is also 0. They cannot bend, so that is why slope is 0 at beginning condition and at first. It is a first end, second end. So general solution, y is equals to cos omega t plus theta, a cos omega by v x plus b, sorry, a cos h omega by v x plus b sin h omega by v x plus c cos omega by v x plus d sin omega by v x. So already I have given the general formula in the previous video, that is the transverse wave only. So please watch transfer waves, their boundary conditions also given against. Okay, here what we have to do, we have to substitute directly above formula. We have to apply these condition directly without doing anything. So this one condition, first we have to we have to apply y is equals 0 at x equals 0, and next this is and these two things. So by using these two things we get the relation between a and c. By using these two things we get the relation between b and d. So keep in mind while doing experiment, while explaining this, please keep in mind. Okay, now general solution over, and applying the boundary condition to the first equation. So boundary conditions y0 at x equals 0, I said you just now. So this and this one time, this and this next time. Okay, so wherever we have the y value there is substitute 0, and wherever x we have there 0. Yes, here 0 0 0 0 0, and we know the cos term, cos 0 is 1, but sin 0 is 0 0, and everything is 0. So that is why these two terms we will get as a and c, and a and c are both plus. So then keep keep c this side only and bring a, it becomes minus. And next time if you have to apply the second bc, this bc if you have to apply, then what we have to do, we have to differentiate the y with respect to x. First differentiating equation 1, right? Differentiating equation 1, what we get, see, this is equation 1, its differentiation. So it cannot be differentiable. Why? Because there is no any x term in these two things in this bracket, so that is why it cannot be differentiable. But here what is the differentiable? Cos, we know the cos ax, its a differentiation is minus sine ax into a, whatever coefficient we have to the with x that comes outside. And here see, x coefficient is omega by v, here also omega by v, omega by v, omega by v. From all the factors omega by v will come, and that is already taken outside here, common. Okay, so that means one step is decreased, reduced, or eliminated. One step is eliminated. Okay, now boundary conditions, these two are, so in the place of here 0, and wherever we have the x there 0. Yes, 0 0 0 0 everywhere. I'll just now I said do cos term 1, sin term 0, this 0 and this 0, so these two terms remains. So b into 1 and d into 1, so then b plus d remains only, and keep d this side and bring b this side, it becomes minus. So d is equals to minus b. Now substitute c and d value in the equation 1. What is the equation 1? This equation 1, in the place of c here it is a c terms. So in the place of c what is substituted? A substituted. In the place of b, in the place of d, minus b substituted in the equation 1. So if you observe the equation 1, see, this is equation 1, here no change, but in the place of c minus a, in the place of d minus b. So minus a minus a minus b. Okay, and now take the common factors. A is common, here we have and here. So then this term in the bracket outside is a, and the remaining here b you have, here b. So b is outside, sign and this sign here. Okay, common factor is taken simply only. Now applying the second bc also we have, that is at x is equals to l. Already x is equals to 0 value is over, first end is over, next end we have, this is the next end. Y is 0 at x is equals to l. Y is equals to cos omega t plus theta into this is right. So directly substitute the terms. So that means this equation is written here once again. And wherever we have the x value, there l value you have to substitute here, l. And y value is y 0. Okay, so then if you bring this bracket this side, it becomes 0. Only inside bracket this will remains. Okay, it is like this. And bring this bracket this side, and keep it keep this here only, and bring this is this side. So here if you bring it outside of the equal, then what happens, it is already placed we have, we bring this side, then it becomes minus only without changing anything, only beam sign will change. Okay, now differentiate equation 2. What is the equation 2? Right, so this is equation 2. So to this equation we have to differentiate equation 2. Then so cos is as it is, cos omega t plus t as it is. So here already written, no need to see that. So it's a differentiation as it is only. One time differentiation means omega by v comes one time only outside, and cos term is a sine. Okay, so it is hyperbolic function. So one thing here we have to remember, cos hyperbolic differentiation is always sine hyperbolic sine hx only. Sine hx differentiation cos hx, so you cannot get any minus and plus, any minus, only plus term only. But in terms of cos, simply you have the cos x, its differentiation is minus sine x, but in hyperbolic it is not like that. Now see, this is a differentiation, it's a right, it is a differentiation over. Now substitute these values substitute here. So in the place of here 0, and where you have the x value, there substitute l value only. So l value here and here also, at the 4 places it is substituted. And bring this side, it becomes 0, only this will get right. And among them, so it is like this is. And now bring this bracket this side, it is plus. If you bring it outside of the equal, then it becomes minus. So dividing equation, see here, the first equation is where this is the third equation, it is a fourth equation. So 3 by 4, do it 3 by 4, right? So dividing equation 3 by 4, we get what we get here. Third equation, it is a fourth equation downside. Then from this a gets cancelled, and minus b is also gets cancelled. And now cross multiplication means like this, we have to multiply. And here cos this term, whatever you have, the same term we have here, so that is why it becomes whole square. And this c here my plus you have, this side minus, so that means a plus b into a minus b formula will get. So that means a square minus b square term. Okay, next time see, this is a minus b form, whole square, a square plus b square minus 2ab. And see, these two are as it is written this side. Okay, now what you have to do, you have to bring, so these two terms this side. How? So right, first this is as it is. Okay, now bring this is this side, now it is plus. If you bring this side, it becomes minus here over. Next this right here as it is. Next Now bring this is this side, it is minus. If you bring this side, it become plus. Okay, and remaining these two things right here only, make it is equals to 0. Okay, so keep it in mind. Why? Because how I have done just now, I explained. And here this term, its value is 1 in hyperbolic function. Hyperbolic function, cos square theta, cos square h theta minus, not plus, minus sin square h theta is equals to 1 only. But not in general formula, cos square theta plus sin square theta is equals to 1. But in hyperbolic, here minus will get. So that is why here for so this value is 1, its value is 1. Okay, so here it is 1, it is 1, in between them plus is there, so that is why here 1 1 1 plus, and it is minus as it is, minus 2 as it is. So these are the formulas. And 1 plus 1, it is 2. Next, and bring this plus 2 this side, it become minus 2. Minus 2 minus 2 gets cancelled, here 1 we will get. And it's in terms of tan and a tan hyperbolic function formula. So this formula can be written as in terms of tan. So this is a tan formula. Next, the graph. If you draw a graph in between tan omega L by 2L and tan H omega by 2L, these waves can intersect. Generally these produce the waves like this, waves they produce around. Okay, now these tan and tan hyperbolic intersect where, at 3.012 pi by 4 comma 5 pi by 4 comma 7 pi by 4 comma 9 pi by 4 and so on. At these values only these two things can intersect, their wave can intersect. So therefore we can write omega L by 2 pi omega L by 2v is equals to pi by 4 into these are. Okay, now v value, we know the v value from transverse wave equation, v is equals to under root omega ck. So substituted here. Okay, so and into pi by 4 pi, so these are the as it is. Squaring on both sides, up squaring, so all r can be squared. And now omega gets cancelled, 1 omega will be there upside. And 4, 4 square means so 1 4 will be there. Okay, now keep omega this side and remain things bring this side. So ck goes upside, L square comes downside, right? And this bracket cannot be changed. Omega is we know the omega value, and it is as like this, and pi 1 pi gets cancelled, 1 more pi will be there, and bring to this side. So 2 4 ja 8, 2 4 ja 8 here. Okay, this is, and it's general formula. So general can be written as in general a fn is equals to, so above formula only n is attached to the above formula only here. So fn is equals to pi ck by 8l square into these values. So if you write fn is equals to this into this, it is called fundamental frequency. This into this, it is called first overtone. This into this, it is called second overtone. So then n value you have to change continuously. N is equals to 1 means this time into this. N is equals to 2 means this time into this. N equals 3 means this time into this. Okay, like this we can write all the frequencies for all the overtones also. So first frequency generally we call a fundamental frequency, and next frequency we call, when n is equals to, we call it is first overtone only. If n is equals to 3, second overtone, like this. Okay friends, thank you.